Hello, everyone. Welcome to the C3 AI webinar series. My name is Angelo, and I'll be your moderator for today. In this webinar, we'll be discussing how data scientists can accelerate AI application development using the C3 AI platform. If you have any questions, please submit them in the Q&A window, and we'll have time to answer them at the end. Today, I'm excited to be joined by Mehdi Masumi, Vice President, Data Science. I'm also joined by Amir Degoshaya, Senior Manager, Data Science. To start off our webinar, I'll hand it off to Mehdi. Thank you so much for joining us today.
Thanks, Angelo, and thanks everyone for tuning in and joining us on this webinar. In the first half of the webinar, we'll be sharing some insights about our work in the last 15 years almost, building and deploying and scaling enterprise AI software, and lessons learned and our perception of the today's state of market, and why we believe data scientists should and can be a critical component in this application development process and team. In the second half, I'm joined by my colleague Amir, who will walk you through a live demo of the software that will show a very complex yet common ML problem that a lot of you might face today, will face in the future, and how C3 AI platform can help you solve that problem and do so much with so little code. So that will be the agenda for the webinar today. Before we get started, I would like to set the context for 2 points from the title of the talk. You can see that we're going to be talking about enterprise AI application. So I would like to clarify and describe what we really mean by enterprise AI application and what we don't mean by it. Enterprise AI applications are not, business intelligence dashboards that happen to have machine learning results reflected on them and included in them. They are, in fact, full-fledged workflow-enabled applications that solve a real business problem with the help of AI, and AI is really at the core of the applications, as opposed to AI being an afterthought. So that's the context in terms of what we mean by AI application. And in terms of empowering data scientists to be involved in this team, we believe that the role of data scientists should not stop at the prototyping phase, which might be the case for a lot of companies these days. We believe that data scientists, in order to bring their AI insights and operationalize them, should be part of this platform, this application development process, to put their AI insights and operationalize them and put them in the hands of decision makers for optimal decision making at the company. So with that, let's get started. A little intro about the company. C3 AI is an enterprise AI software company. We provide software as a service or SaaS solutions that enable a lot of large organizations to rapidly design, develop, and deploy enterprise AI softwares that lead to a lot of economic benefit for the customers and for their shareholders. And thereby, we enable and accelerate their digital transformation journey. Over the years, we've been working with a lot of companies in different domains, most of which being world icons, and from financial services, working with banks, manufacturing, aerospace, and healthcare. And what has been interesting over these years is that each of these verticals, each of these companies have brought us interesting set of challenges that have helped us really mature and robustify the platform and harden its capabilities, and essentially enable us to take the same platform and apply it to all of these different use cases and different domains, building AI applications using the platform. Along with these customers and these relationships that we have built with them, we oftentimes start from a use case that is a critical pain point for the customer, a business problem that we want to solve, and they turn into one of these applications. It is an expanding and growing list of applications that we have as turnkey solutions that companies can come and adopt off the shelf, or we can take, configure them further, or even start from a new use case and build new applications for them. Examples of these, to give you a sense of what are the type of problems we're working on, include reliability, which is one of our most popular applications. It's about monitoring health of large critical industrial assets. Example include inventory optimization, which is about the right sizing inventory and helping the material planners, supply chain personnel and managers really be able to understand where to stock and how much to stock each SKU, and provide visibility to their supply chains. And demand forecasting, which is another common use case across multiple of these verticals, that enables companies to get a very granular level and picture of forecast of demand for each SKU at different product category level, at different levels of abstraction, and being able to manage those demand forecasting models at scale. So as you can see, we have been working with a lot of companies, working in a lot of use cases, and we believe we have a pretty good sense of the state of the AI in the industry today. Recently, we came up across with this report by McKinsey & Company, which actually reiterated our understanding of the state of AI. This report talks about how 50% of companies relatively have adopted AI. And here the key word is adopted, and what we mean by that. While as we double click and we go further down the report, there's only a fraction of those companies that have what it takes to scale AI. So these 50% of companies, those are the ones that have adopted AI, could be in a very small scale prototyping phase and across one business unit. But as you can see on the right-hand side, the list of capabilities that are required to go from a small scale prototype all the way to scaling AI, as these requirements become more stringent and more complex, there are fewer and fewer companies who are equipped with what it takes to scale AI. Capabilities like full lifecycle automation of model deployment, which only really 10 to 20% of respondents from the survey, apart from the AI high performers, are equipped to address. So with that, there's a spectrum of customers and companies out there. Companies who have recently set up their AI teams and have tasked them to figure out how AI can help them solve business problems, to companies who have been dealing with it for a longer time and have solved a few business problems so far with their data science team and AI teams. They have one or multiple prototypes even today that works relatively well in solving those business problems, all the way to customers who have a long list of applications live in production. And there's a whole spectrum in between, right? You might find you and yourself and your team and your organization somewhere in this spectrum. But what we see is that a lot of companies out there are actually stuck in the left-hand side of this spectrum, where they have prototypes, where they have data science teams that are able to solve problems on a smaller scale. But as soon as it gets to really operationalizing those AI insights coming from these prototypical models and building applications around those and scaling those applications, they're really struggling. And what we've done here, we have really categorized pain points into a few scenarios where we see customers are facing from cases where the state of AI is like this picture, which is majority of our customers and companies out there, in which they have adopted a cloud platform or cloud solution. They have integrated and ingested their data into data lakes, but they have really directly connected ML products, Jupyter Notebooks, Cloud ML tools, to these data lakes, which leads to a lot of duplication of data. It doesn't allow for a common data model. It doesn't allow for a common storage for features, for models, for pipelines, and it does not really allow reusability of software components. And what happens is that every time you solve for a use case or you're working on a problem, you tap into data, start from scratch, write a notebook to perform data pipelines, data cleansing and inference. Feature engineering would be another notebook, model training, model deployment. And you end up with this spaghetti of notebooks and models, and soon enough, it will be an intractable problem. We believe this does not work and this does not scale. Going back to these scenarios, starting from the first leapfrogging from prototyping to an application, there are a specific set of challenges. We are talking to companies that constantly tell us one of the challenges they're facing is that their teams are siloed. The data engineering teams, data science teams, software engineering teams that are responsible for different parts of building AI solutions are completely siloed. There's not a communication, there's not a means of collaboration for these teams. Even if when they get over that hurdle, there are challenges of putting these models into production, how to feed the production models with new production data, technologies like change data capture and others. How do you, as they continue to improve the models, how do they validate new features, deploy new features, manage their runtimes? How do they make sure that the same runtime exists from prototyping to production? How do they serve models on live systems? When models are in production and you might have a champion challenger configuration, how do you make sure that you route prediction requests to the right model that at the time is a champion or challenger? How do you automatically store prediction results and monitor model prediction and model health? How do you provide interpretability as part of your application? And essentially automating the whole life cycle of AI model development is a pain point right now. Model drift detection and retraining, again, are more advanced topics that a lot of companies dream about today. As we move on, there are fewer number of companies that have been able to turn those prototypes into applications, but now are facing challenges in terms of how to scale that application from a small subset of the population, a small subset of the enterprise footprint to the whole enterprise. You might be working on a reliability application for wind turbines, which you started solving the problem on the prototype and put that into production with data from one specific country, with one specific manufacturer. Now you want to go to the next country. You want to go to the rest of the footprint of the enterprise and scale your application to those geographies, to those assets and facilities and so on. You have to deal with different IT systems. You have to deal with different data sources. So if you have hardwired your ML predictions to the data source, now all of a sudden you have to work with an Oracle data as opposed to SAP data, and everything was going to fall apart. You're dealing with different setup and configuration for each business unit, the way they run business, the way their assets are configured. And there are different ML training and inference requirements for each subpopulation. These are the challenges as you scale the same app. And then really when you look at how this is done today is as follows, right? You start from a training data. The data science team might ask a data engineering team to extract data for them. So you build custom data pipelines, you train models, iterate. Once you're happy with your model, you essentially pose that as an endpoint, and you have to create prediction pipeline. Now with production data, you have to recreate those pipelines for data and for ML. You end up essentially writing a lot of custom logic to orchestrate data and models. We have talked to some companies where they've had to adopt a whole new CI/CD solution and configure it to this very task of managing data and ML pipelines. And the list really goes on, right? You need to have take care of model registry. You need to take care of runtimes, serving models, champion, challenger. And this list, the last 5 points, is really a dream for some of the companies that we're talking to, that they hope they get to over the next 2 years. And guess what happens when you get to those in 2 years? There's a whole new set of requirements. And this is, you're really always running behind with this methodology. Let's talk about the last set of scenario where you have one application that you have scaled out somehow successfully. And now you want to build the next application, solving an adjacent use case. Let's say you have a reliability application live and you want to use the same data that you have with the same features, the same sensors, to now optimize the process that is used to run these assets. What happens is that you always have to start from scratch. You have to start establishing a new data model, a new data access layer. You have to recreate your data pipeline and features. It's very difficult to reuse the work of different teams building previous applications. Their codes are buried in that spaghetti notebook that I showed earlier. And collaboration and reuse is not really enabled. Rewriting model deployment framework is what usually people end up doing. And really reuse across use cases is very difficult. You cannot avoid reinventing them. So as it's clear, this way of going about solving the problem is very cumbersome for one application, let alone having to build, manage, and maintain multiple applications. So it's really starting to become an intractable problem. And just as a recap, this is really the state of AI in a lot of enterprises today, unfortunately, right? You end up with this spaghetti of notebooks, and which doesn't promote reusability of the code and collaboration. We've been hard at work over the last 15 years in designing and building a new technology stack that we believe solves all of these problems. We have a differentiated and patented approach to solving this problem, enabling scaling out of AI solutions across enterprise. And that is done via an abstraction layer for designing, developing, deploying, and operating large-scale AI applications. The approach is that C3 AI sits on top of your cloud infrastructure and investment that you might have in platform services. We use those platform services and cloud investments and infrastructure that you have, and we are solely concerned with quickly building AI applications and scaling them out via the platform. So in that regard, we are essentially, you can see that there is a new abstraction layer that is sat in between the data lakes and the end solution that you want to get. We get rid of that spaghetti of notebooks, and we essentially derive acceleration of development and deployment through a reusability of software components. So reusability extremely important here. Not only software components, but also pre-built AI applications. You can take those and configure them for new use cases. The advantages are that you have a predefined data unification layer that is business friendly. It adapts and is consistent with your business realities and source data systems. We provide AI machine learning capabilities, continuous data processing, elastic compute, and all of this is really backed by the model-driven architecture that is the underpinning of the platform and the invention, which allows, by keeping track of metadata, allows for defining declarative object models that enable code reuse. So that is really the core component and the core value add here. Just to recap, that this way of going about building enterprise AI software is not efficient, going horizontally, and it is not scalable and is not tractable. But what do we do? What do we do differently here? What is our solution like? In C3's approach is really about establishing, instead of custom data and ML pipelines, establishing a reusable declarative objects that spans across the whole life cycle of ML and AI development. This, think of it as an abstraction layer that essentially is put in between source systems, Oracle, SAP, whatever, ERP or other source system that you might have, with the rest of the application code. So this really provides a protection against changes in data ingestion, changes in data persistence technology that you might have over the years, and future-proofs the code that you write on top of this unified data model via this abstraction layer. Down the road, as we build these components in order to serve the application development and application deployment, we are working with completely reusable, 100% reusable software components. And that's indeed a design requirement for our organization. Feature store, the way it's differentiated is that we manage feature definitions. We keep track of feature definitions and the metadata associated with that. And we only materialize those features when and if needed. You can obviously, take a snapshot and store it in a low cost storage. And that's the next step would be model registry, where you tap into the same feature store, access data, materialize data, and you start training models, essentially exposing them as RESTful APIs in QA and prod environments, and you can, on the same environment, via model deployment framework, you can promote those to live. You can establish champion challenger configurations, and all the backend is really done for you, and you are only configuring the software at a high level. This is the backbone of a lot of our softwares that have enabled companies and customers train and have thousands of live models in production, making predictions every day. To give you and show you an example, one of our flagship customers, Shell, has used the same technology to really scale AI from a prototype phase, which is where they were, where we met them, to now having more than 16,000 models live in production, making predictions every day. One thing to notice on this plot is that, as you can see, thanks to the reusability and the collaboration that is enabled by the software, the time that it takes to go live and deploy the software and one application at every asset or facility shrinks over time. And that's where you want to go. You don't want to start from scratch and spend exactly the same time for your second deployment and your second app as you did for your first one. And the third one and fourth one should only get easier And via reuse of these software components, you need to gain efficiency. And that's exactly what they are realizing now. To give you a context in terms of complexity of these applications, they have, this is for 1 year ago when we published this joint report, where they had 10,000 pieces of equipment. Today, they have more than 16,000 pieces of equipment being managed by C3, which ingests 20 billion rows of data weekly from 3 million sensors. And making more than 15 million predictions every day. So this is really the scale and complexity of applications that we have been able to manage thanks to this model-driven architecture platform. I would like you to take two messages home, the two takeaway messages for us. The first one is enabling collaboration, how the platform enables your teams from data science to data engineer to software engineers to collaborate via a common platform. If you look at this picture, the C3 AI platform sits on top of the platform services. And thanks to the common data access layer, the data engineers, data science, and application developments are all coding and working against the same code base, the same package. And they share and reuse components that they build or the adjacent team is building. And they compose those and make them more complicated as time goes by. So collaboration is enabled. If you look at the traditional software architecture at a company, you notice that there are data platform teams, there are data science teams, they are separate from ML ops teams, that are separate from application teams. And these teams are designed not to talk to each other. There are oftentimes implicit or explicit dividers between those teams, and the handshake is not done very properly, and the collaboration is not enabled properly between those. What the C3 AI platform does is via the introduction of declarative objects and abstractions at all of these levels, from data abstractions that you could interact with any storage technology, to declarative ML pipelines that enables you to unify the approach to ML model training, inference, and managing runtimes, to UI development using declarative UI capabilities. We provide this full code, low code, and no code developer experience that includes platform services such as multi-cloud, auto-scaling, security, authentication, and so on. That is really what you need in order to scale AI applications. And the second takeaway message is the reuse of software and how we enable that leads to scaling and leads to efficiency. If you look at this picture, let's say, if you remember one of the first few slides, we start from prototyping, we have our first application, and we scale it out to the whole enterprise. Let's say we are there, and you have integrated disparate data sources on C3 platform. You have a unified and connected object model that captures your entities that are relevant for this use case. On top of that, you have ML features, you have train ML models, and you build an application. As you go from the first use case to the second one and start adding data sources, you do not need to start from scratch. This is, again, a very important point to take away with you. As you add new data sources, the data model is open and extensible. You can expand the data model to support addition of new features, addition of new use cases, and you really start to build the Lego blocks, put them next to each other as you go from the first application to the nth application, using object models that are reused and extendable, ML features that are cataloged and reusable and shareable, ML models that are managed and deployed at scale, and leading to AI applications deployed at scale. So hopefully the two messages come across. And in order to go even further on showing you how this is done, I'm going to ask my colleague Amir to give you a live demo of the software that solves as I mentioned earlier, a very complex machine learning problem, if you think about it, yet very common one. We're going to configure ML models and deploy an application to a large fleet of wind turbines. We start from importing two models, a Keras model and a random forest model. We load those models from a registry that could be by default available on the application, or these are models that our colleagues in the past might have trained and built and made available. The core of the problem is as follows, and I would like you to think about how generalized this problem is. We have a population. This population in this case happened to be wind turbines, but if you are a bank, this population could be customers. And if you are a supply chain company, this population could be SKUs. And if you are a retailer, these could be product categories or items and so on. Oftentimes, you need to create clusters of these subpopulations based on some attributes. In this case, we are clustering them based on the manufacturer, and we're training a model for all manufacturers, for all wind turbines where the manufacturer is Siemens, and one where the manufacturer is GE. But you also want to have a champion challenger and configuration where you want to have on top of that Keras model that you train for the whole subpopulation, you want to also have a random forest model trained for each wind turbine. And last but not least, you want to deploy and promote these models and have a champion challenger configuration and have a system live and scale it out to infinitely large, virtually infinite large number of assets. So with that, I'll ask my colleague Amir to take over here and show you how this is done very easily and seamlessly on the C3 platform. Thank you.
Thank you, Mehdi, for setting the context. So I think you can see my screen now. To go through the workflow that Mehdi just described, I start my work in C3 AI Studio. Here at the Studio homepage, the first thing I can see is the environments and applications that I have access to. As Mehdi mentioned, for this demo, I know that I'm going to be expanding a predictive maintenance application to a new fleet of wind turbines. So to start that work, the first thing I do is I will go to my application canvas, which I have open here. On the canvas, I can see the full lineage of data in my application, and I can see the main entity types that I'll be working with. For example, I see that wind turbine is a central type, naturally, that I'm going to work with. I'll see details about this type, including the different fields that it has, and also the connections to the other entity types in my data model. Moreover, I can preview data that I have available in my application. So for this demo, we see that we have data for 4 wind turbines. So now that I'm familiar more or less with the data model, the next thing I want to do is to go to Jupyter to inspect the data and the models that I have available more closely. So going to Jupyter, before going through the full demo, I want to emphasize 2 things. One is that over here, I am still interacting with the same data model. So I have the wind turbine type, and I can eval and show you that we have the same 4 assets. So exact data that I saw in Canvas is available to me to interact on Jupyter. The second thing that I want to reiterate is that although here we'll see a use case for predicting the risk score of mechanical failure, the abstractions that we'll see and the main steps of this workflow are shared across many different use cases. So you can imagine that we could be predicting the risk for delay in delivery a package or a risk for a loan default using a very, very similar workflow. Okay, with that context, I will start by inspecting the models that I have available in my application. I'll also zoom in a little bit so you can see this better. I see that I have two models available. I have a random forest model and an XGBoost model, and I see that they have something to do with reliability. I also see that these models have a pipeline and two feature sets attached to them. So now I want to go and double click on each of those elements. First, I want to see the exact machine learning technique that was used for this problem. The models that my colleagues have previously developed, they have proved useful maybe for another fleet of wind turbine, someone else, but now I want to really know what was the machine learning technique used there and make sure this applies to the problem that I have. For example, in this first pipeline, I see that I have some pre-processing steps followed by a random forest classifier, and then I can also get an idea of the output heads. I have a probability output, I have a precision metric, and binary predictions. Similarly, I can inspect the other pipeline that I have in my application. Now, let's say big picture, this pipeline makes sense. I want to use it, but I want to make sure that all the details apply to my use case. So I can even look at the authoring code for the pipeline. I can really copy paste this code and remove any steps or change or add any other steps that I see fit, so I can have full control over customizing this pipeline. Next, I want to look at the feature set. So for the random forest model, for example, we see that there are two feature sets available, a label feature set and a input feature set. If I look at the input feature set, I can see more details. I can, for example, see that it's comprised of three features that look like they're engineered based on some measurements. Similar to the pipelines, I can look at the authoring code for these features. So I would exactly know which source type was used and which transformations were applied to get to these feature values and this feature recipe. If I see fit, I can make any changes that I want to this feature definition. And I can also evaluate these features for any of the assets that I have available in my application. For example, here you see an example evaluation for turbine 3, and I can interactively explore the results using the pandas-like APIs of the C3 data interface. As an example, I'm displaying the first 5 rows here using head and calculating the summary statistics using describe. One thing I want to highlight here is that you can imagine for an API like describe, there's a lot of computation that is going on for calculating all of these statistics. All of these calculations are happening on our distributed cluster. And only the final result is showed to me, the data scientist, in this notebook, right? So this ensures that for use cases where I have large-scale data, I wouldn't be limited by the computational resources available to me in my Jupyter service. And then finally, we can get a sample of this data and visualize it and interactively do more exploration until we are confident that we are okay to start training models. Okay. As Mehdi described, we want to deploy 2 models for each asset using a champion-challenger strategy, right? I want to deploy one model that is trained using the data for all the assets from the same manufacturer, and I also want to deploy for each asset, and then deploy that to each asset that fits that description, and also train one model per asset that's just using the data for that individual asset. I can set up all of this complex training strategy in a few simple steps. First, obviously, I will specify the training start end, and I specify my holdout test set. Then I'll specify my training strategies. This is really the instructions for how to get the data for training these different models. For example, here, when I have specified group by manufacturer in my training strategy. What I mean is that I want to combine the data for all turbines with the same manufacturer for training this model following this strategy. Next, I will define model templates. So this is really a wrapper around the models that we just looked at. So we will have 2 templates. And then finally, I'll put the template together with the strategy and define a training group. So 3 simple steps. I'm ready to go perform the training that I described. So as you can imagine, as Mehdi showed you in the slides, for a typical application, it's not uncommon to have tens of assets and hundreds of models deployed, right? So you can imagine that keeping track of all these models, like knowing like which specific model belongs to each specific asset, and just orchestrating this training can be a pretty tedious task. Training job helps us abstract a lot of these problems, right? Moreover, it will also help distribute the training across the C3 cluster. So I don't need to really worry about the computational resources that I need for this task. Once the job is done, I can inspect the results. And in a very quick summary, I can see that indeed training was done following the instructions that I provided. So I have 2 models that were trained using the manufacturer filter, and I have 4 models that were trained using the ID of specific individual turbines. Now that my models are trained, I can simply deploy them, calling the deploy API. So after this step, you can see that for each of our turbines, we have 2 models, and the initial state of every deployed model is a candidate model, right? So next, I want to promote the best performing model as a champion. I just simply do this by looping over the asset and scoring each deployed model on a holdout test set. And I'll just promote the best performing model to be the champion model. So after this step, we see that for each of our assets, we have a champion model and a candidate model. So finally, when I have my model deployed, I can make predictions using the deployed models. To illustrate this, I'm getting one of our assets, so here wind turbine 1, and I make predictions by simply calling the process API on it. So the thing I want to highlight here is that when I call this API for making predictions, I just need to specify the start and end date for the predictions, and optionally the status filter of the model that I want to use, right? The model right now has all the information and instructions to get the exact data that it needs, and it also has the instructions for persisting the predictions to the right part of my data model. So here I can see that after this step, my wind turbine prediction type is populated, and I can inspect some of those populations. After this step, I want to show you 2 last things. One is that everything happened on the same data model. So if I go back to Canvas and then preview data on my wind turbine predictions, I can see the same predictions. And then finally, if I go to the model ops view of my application, I can see that I started from 2 untrained and undeployed models. And then finally, when I was done with this notebook in these very simple few steps, I have 6 models that are, some of them are serving multiple subjects and some of them are serving just one subject, right? And I can also see that each of my assets, actually in the deployments tab, I can see that each of my assets has 2 models deployed. I have a candidate model and a champion model, and I can even go ahead and change the status of these models here if I have the right access. So for example, I can retire a model. I'm not going to do that right now. So to summarize, we started from a blank application, right? And in a very few steps, just starting from 2 untrained models that my colleagues provided me, we were able to complete one cycle of a complex model deployment strategy, right? Now I'm confident that for my new assets, I have good baseline models deployed and all the functional machine learning pieces of my application functional, right? So me and my team can now focus on the assets that don't have a good model serving them and spend most of our time on focusing on those models and improving performance using additional pipeline tweaks to our pipelines or feature engineering. That concludes my demo. With that, I will hand it back to Angelo for Q&A.
All right. Thank you, Amir. Thank you, Mehdi, for the great presentation and the great demo. As a reminder to our audience here, this is a live webinar. So if you do have any questions, please drop it in the Q&A box on the lower left-hand corner of the screen, and we'll be sure to get to it. I do see we got a good amount of questions here so far. So Mehdi and Amir, I'll start with you guys. Actually, how about let's start with Mehdi for this question. What percentage of code can be reused when going from the first application to the second to the third?
Over the years, we had a very good sense of the reuse that we were getting ourselves across multiple applications. But very recently, we actually went on and did an analysis, put a number on that. In one of our COEs or Center of Excellence customers, we reviewed the lines of code that was written for the first use case. And then we look at the ensuing second and third use cases. And those are applications, essentially. Think of it as the first app solving one problem, second and third app solving different problems, but adjacent and related to the first one. The numbers were staggering. We realized that the second use case, we can save 40% in terms of lines of code written. And in the third use case, which we're leveraging components from the first and second use case, we were able to save 70% in terms of lines of code that you would have to write otherwise. So we're talking about really large thousands of lines of code and many hours of development from developers working on these apps.
Great. Thank you, Mehdi. Let me see. I think on this question, I'm gonna switch over to Amir. Can I change any part of the pipelines and features that you showed in the notebook? And is this process fully customizable?
Great question. Yes. So as I showed in the demo, we can get the full authoring code for both pipelines and features and feature sets, right? So you can fully inspect them and literally copy the authoring code, make any changes that you want, and then update the feature or pipeline definition, or just create a new one if you want. So full flexibility.
Great. And Amir, while I have you, I think I'm gonna stick with you for this other question we got in. So, are you using your own custom Jupyter image, and what's so special about
it? Yes, we are. Maybe for that, let me quickly share my screen again. So you can see the C3 logo up here. So yeah, this is definitely our custom Jupyter image. Maybe I'll just highlight a few things. One is that you see that I was using the C3 variable here, basically accessing the C3 Python SDK without needing to authenticate. And I had access to the same data, and I also had access to the same application that we saw on Canvas. So authentication is taken care of automatically. I can change and configure my resource profiles based on the access that I have. Here, actually, if I switch to the files, you see this blue checkbox it basically means that all of my work is being version controlled and saved. So I'm actually sure that if anything happens to my Jupyter service, I'm not gonna lose any work that I have in progress. Some other things is, maybe one more thing to highlight is that I have access to simple runtime management. So for example, I see that I have one runtime installed here and many more available. And for example, if I need a library like TensorFlow, I can see that there are actually many runtimes here that readily provide TensorFlow. I could quickly install them and use them. So here are just a few highlights. There's a lot more details to our Jupyter service, but it's like basically the summary is that it's tightly integrated with all of our other services and makes developing on C3 a lot easier.
Great, thank you, Amir. All right, gonna switch over to Mehdi for this one. And we're going down the list here. So again, to our audience, if you do have any more questions, please feel free to ask, and we'll make sure we'll be able to get to it. All right, Mehdi. So for this question, how would migration go from V7 to V8 for deployed models and associated processes?
Yeah, I think we are, as correctly mentioned, in a transition phase where we have new customers being brought on V8, but we also have a lot of existing customers on V7 that need to be migrated. The team has worked on automating that process as much as possible and coming up with, again, the same off-the-shelf solutions on V8 for a lot of our applications, where you could either start from those or migrate the code that you have done automatically to V8. It's been also via, again, the same principle that we reuse and we enable collaboration. Even that process of migration has been gaining speed as we do the first app migration to the third one, to the second one, third one, and fourth one. So we're seeing the same pattern of really speeding up the migration of our applications going from V7 to V8. Okay. I don't know if Amir wants to add anything to this.
Yeah, nothing major to add. I think basically a lot of our customers are getting a lot of value from V7, and we want to make sure that we don't disrupt that. But like the plan is to move new use cases and all the existing use cases also to V8 as soon as we can.
Okay, great. I'll go through a couple more questions, and I think that'll be it for the webinar. So last call here for questions. Mehdi, back to you. This one, I think, is in regards to one of the slides you showed earlier in your presentation. You mentioned there are more than 10,000 ML models trained on the Shell application. Are these models trained by data scientists, and how many did it take to train that many models?
Yeah, that's a very good question, and I assure you, no company has that many data scientists today with PhDs, with the right set of skills to enable such a scale. So what we did, which was quite innovative and new at the time when we went live with this application at Shell, was that we really put a lot of the bells and whistles and a lot of the API calls that you need to get the data, cleanse the data, add and apply masks, exclusion masks to your time series data, train models at scale, running batch training jobs and so on. We put them right in the UI, so that the users of the app, which actually happen to be not data scientists with PhDs in computer science, but a process engineer or a chemical engineer who happens to work at the facility, work at the refinery, and are very familiar with those assets. but they may not have the coding and data science skills. So we really enable those personas to be able to train models at scale, and thereby we have really democratized AI to personas beyond data science. So in this case, there are a large number of process engineers globally that sit in these assets and facilities globally at Shell that are responsible for maintaining the application, responsible for training new models, making sure models are fresh all the time. As they start to drift away, there are triggers that sends an email to the person who trained those to come back and retrain a model, and they can even set up automatic retraining. So through automation and through the use of software, we have really gone beyond needing data scientists to train every single model and democratize the AI in that way.
Perfect. Thank you, Mehdi. All right, Amir, I'm going to ask you one more question, and then Mehdi, hopefully I think we could answer this one in the last couple of minutes we have. But Amir, last one for you. What if I need a different library compared to what you use in this demo, and how easy is it to customize that?
That is another great question. Let me quickly share my screen again to just show it to you in the product. So as I mentioned, you have runtime management. So you see a lot of the libraries that are available here. I think most of the things that we ran into, for example, I don't know, let's say you want Hugging Face for a use case, we actually provide out of the box. So you can just install the runtimes. Once you install it, these are runtimes that you could use in the pipelines. So you're actually sure that whatever you use in your exploration and prototyping would actually work in production. And if what we offer out of the box obviously there's a lot happening in the ML world, and you might want different runtimes and different libraries. So you could define your custom runtimes here and basically specify any packages that you need. I think to the best of my knowledge, we provide one of the only and the best UIs for resolving packages and runtime management in general. So you have full flexibility to pick any library that you want.
All right, thank you so much, Amir. All right, Mehdi, I'm going to ask you this. Hopefully this is a good last question here. I know we also respond to this individual separately, but for everyone else who also might have the same question, how can we get onto your pilot program?
Good question. Yeah, if there is what we presented resonated with you and you want to leverage these increased productivity and efficiency, we have this pilot program where there are sufficient instructions on the website. You can reach out to us, to the marketing and sales teams. We typically either through the website, reading through the instructions for pilots, or reaching out to the marketing and sales. The next step would be to essentially start by identifying a use case that is in fact a pain point for your business that you want to solve. We will have our teams assembled, and we'll get engaged in a pilot to demonstrate how quickly we can have a live software. We will be live within 6 months, and after that you can keep the software as you wish, and there's a consumption-based pricing after that.
Perfect. Thank you so much, Mehdi, and thank you so much, Amir. And actually, as a reminder to our audience, if you do want to get in contact with one of our team members, there is a book a meeting button down at the right-hand corner of your screen. Gives you a little shortcut to get in touch. All right, so that is all the time that we do have left for today's webinar. As one more reminder, this webinar will be available online to watch at any time. We're available on demand. You could click on the same link you used to register, and you'll also be receiving an email with the link shortly after today. And if you enjoyed today's content, please follow C3AI on LinkedIn, Twitter, and YouTube. Thank you so much, everyone, and hope you enjoy the rest of the day.